Okay, so instead we would separate it completely into ions. Carbonate solid. And that, my friends, is the net ionic. So one of the types of reactions we need to learn to write is what we call complete ionic and then net ionic. So it's kind of what it sounds like. Complete ionic is when we are going to write all soluble ionic compounds and strong acids and bases separate as ions. So for example, if we had sodium chloride in aqueous solution, we would write it separate as Na plus aqueous and Cl minus aqueous. Okay, so instead we would separate it completely into ions. If we had calcium hydroxide, that's a strong base, we would write the calcium ion and then 2 hydroxide ions. So you get the idea. And then the net ionic, you're going to love this one. This is when we're going to cancel some things out and we're only going to show substances that are directly involved in the reaction. And we're going to eliminate what we call spectator ions that don't really participate in the reaction, but they're just hanging around. This will make sense when we do an example. So let's get down to one. This looks really atrocious, but hang with me. I've got a reaction written in words and I've got it written in formulas so that you can see it. Manganese chloride and ammonium carbonate making manganese to carbonate and ammonium chloride. Double replacement reaction. So what we're going to do is first, let's look for aqueous. Who in this reaction is aqueous? I see aqueous here, aqueous here, aqueous here. But note that I do have a solid, right? So I am not going to write that solid separate into ions. So let's write the complete ionic. All right, so here comes my complete ionic. And you're going to need a lot of room because there's going to be a lot of participants here. So manganese 2 chloride, let's break it apart into ions. So there's manganese 2 aqueous, and then he brings 2 chlorides aqueous. Break apart the ammonium aqueous and the carbonate aqueous. Okay, those are all my reactants. All right, so I've got this guy, I've got this guy, and they're soluble, so I broke them apart into ions. And then the next one, the manganese carbonate, since it's a solid, I'm going to leave it as a solid. Because if it's a solid, it's not soluble. And then let's break apart our ammonium and chloride. And those are aqueous. Okay, there you go. There's your complete ionic. Everybody who's soluble, break them apart, write them as ions. Now, this is going to be the fun part. Let's write the net ionic, and I'm going to do it right underneath. Okay, so first thing I want to do is remember that term spectator ions. Let's go through and get those spectator ions in our reaction. And those are ions that are just hanging out before and after the reaction. Well, I noticed that chlorine, the chloride ion is a reactant and a product. It's just sort of hanging out. So I'm going to eliminate that. And then I also see the ammonium on both sides of the arrow. Okay, so if we eliminate the ammonium and the chloride from both sides of the reaction, here is the net ionic. All we have left is manganese, that's aqueous, and carbonate solid. And that, my friends, is the net ionic. So the ammonium and the chloride are what we call spectator ions, and they are just hanging out on both ends of the equation. Okay, and we eliminate those to form the net ionic. So practice a few of these, complete ionic, and then cancel out spectator ions to get the net ionic.